Alright, I have another one of these. Question 1. Find the value of 14 factorial plus 15 factorial over 12 factorial plus 13 factorial. We realize that n factorial is n times n minus 1 times n minus 2 times n minus 3 all the way to 3 times 2 times 1, or all positive integers up to n multiplied together. We realize that n times n minus 1 factorial equals n factorial, or 15 factorial equals 15 times 14 factorial. We can then write the equation as follows. 14 plus 15 times 14 factorial, which is 15 factorial, over 12 plus 13 times 12 factorial, which is 13 factorial. We have this, and we factor out a 14 factorial from the numerator and a 12 factorial from the denominator. We obtain 14 factorial times 1 plus 15 over 12 factorial times 1 plus 13 equals 14 factorial times 16 over 12 factorial times 14. Writing 14 factorial as 14 times 13, we have 14 times 16 times 13 factorial over 12 factorial times 14 factorial. Now we cancel out a 14 from the numerator and denominator, and we are left with 16 factorial times 13 factorial over 12 factorial. We write 13 factorial as 12 factorial times 13, and we are left with 16 times 12 factorial times 13 over 12 factorial. After canceling out the 12 factorial, we have 16 times 13 equals 208. Question 2. Factor x to the fourth plus x squared plus 1 into factors with integer coefficients and integer powers. So we have x squared plus y squared equals x squared plus 2xy plus y squared, or in this case, x squared plus 1 squared equals x to the fourth plus 2x squared plus 1. This looks suspiciously like what we have, so we add an x squared to get the 2x squared in the middle, but we have to subtract x squared as well to make it balanced. So we have x to the fourth plus x squared plus 1 plus x squared minus x squared. Group the x squared terms, we have x to the fourth plus 2x squared plus 1 minus x squared equals x squared plus 1 squared minus x squared. This is a difference of squares, so it can be factored further into x squared plus 1 plus x times x squared plus 1 minus x. Question 3. How many obtuse angles does a pentagon with side lengths 3, 5, 8, 9, and 26 have? This is a trick question. This pentagon does not exist, since 3 plus 5 plus 8 plus 9 equals 25. This means that this shape is impossible to close no matter the angle between the sides, since the sum of all the sides other than 26 is 25, which is less than 26. I've drawn it here, so 3, 5, 8, and 9. Even if those angles in between them are really large, the most they can add up to is 25, which would not close up a line that is 26 long. Question 4. 5 people A through E are seated along a line. If persons A and B have to be next to each other, how many ways can these people be seated? We group A and B together as one entity, so there are 4 people left. So there are 4 possibilities for the first seat, 3 for the second, so we have 4 times 3 times 2 times 1 equals 4 factorial, which equals 24. Since we still have the 2 people occupying one seat, and every person can be seated first, we multiply the final result by 2, and we have 48 possibilities. Thanks for watching, and don't forget to subscribe to see more videos similar to this one.